Hello, everyone, and welcome to another edition of Learning Programming in Java. I'm your host, Trey, and today we're going to be talking about object oriented programming. And we've built up all the way up to this point learning arrays, learning um, classes, learning everything that we had to learn, methods, and basically all the essentials for Java. So, now in this video, we're going to talk about object oriented programming where everything revolves around objects. So without any further ado, let's get into it. So I said in the introductory video that we're going to talk extensively about classes, and today is the day. So classes are basically blueprints for creating the objects. It houses the methods and attributes that define the object. Simple stuff, right? Attributes in this case refer to the data fields and variables, and methods in this case are the behavior of the objects in question. Pretty simple stuff, right? So we have a general class outline and it has a format of so. So we have public class, my class, and then we have our fields section here. And we're going to get into that a little bit later on. But we have fields which are attributes. So basically, these are data fields where we declare our data types and everything. Then we got a constructor. Here we have the syntax, which is public my class for this class here, and then we have our values as so, and then we got methods as so. And let me get into what these actually mean. So let's get into what fields are, right? In a deeper context. So basically, fields are variables that define the nature and the state of the object. So what I mean by this is that a field, or let's just say a field, can contain uh, identifiers, and those identifiers can have data types. So we're defining the data types that are available in this class. Let's just say you want to go out, right? Let's just say you want to go to school, and that day you have, let's just say, a course in programming or a course in mathematics. So in your bag is your class, and in your bag, you are going to have a math book and a programming book, right? So that's your inventory. You have a book that is just for programming, and you have a book that is also just for mathematics. So in that case, or with that sense, or with that context, here we have our class, which is our container, and we have our attributes, which we can define as integer, string, double, float, etc., etc. So we do not define these as what they are in the um, attributes section. We can just say int my field or string name, double radius, float decimal, etc., etc. And that's how you declare your field's attributes. But wait, everything is gonna come full circle and you see the importance of everything. This is a simplified video on basically object oriented programming, and I will show you just exactly why that is. So we also have a thing called access modifiers, and I've talked about this for quite a while now. And by now, I'm pretty sure you should have a decent idea of what an access modifier is. But then we're going to look at the types of access modifiers that are actually available in the Java library or the Java runtime environment. So these access modifiers are keywords that determine the visibility of a class, field, method, or constructor within different parts of your code. There are four types of access modifiers in Java, namely public, and this basically means the member is accessible from any other class. So any other class is able to access all the information from this particular class that is labeled public. And we have private, where the member is accessible only within its own class, and we have protected, where the member is accessible within its own package and by subclasses. So wherever it is, if it's a class, only those values and attributes can only be accessed by that class and that class alone. And then we have the default, which means the member is accessible only within its own package. So basically, we have these four types of access modifiers, and these access modifiers can be public static, public class, public all these, private class, private static, private this, private that, protected, and default as well. So these are the types of access modifiers that you can use in Java, and they will determine the visibility of your class depending on other classes as well. Okay, so we've talked a lot about data fields or attributes in this case, but now let's talk about what a constructor actually is, because these are very, very important when you are writing your own class. So the purpose of object-oriented programming is giving you the ability as a programmer to be able to write your own class, to be able to determine everything that you want in your own class, and to be able to execute it. So if I say I have a class that does basic arithmetic, or let's just say a class that is used for mathematics, right? I would declare methods, I would declare everything, and then in the main method, a another user or another programmer is going to say, okay, there's this class that Trey has built, and let me just try to access all the information that is in there. So I would label my class as public, and then every instance of whatever the other programmer is going to use is going to be derived from my class. So basically, object oriented programming gives you, the programmer, the ability to create your own class. Pretty cool, right? So let's get into what a constructor actually is. So a constructor is a special type of method that is used to initialize the object. So here we have our access modifiers. We call this public class, my class. And because this class is public, so meaning all these data fields are public as well. Keep that in mind. And a few information before you get anywhere. A constructor has got this syntax here, public my class. And a constructor will always have public without any static or anything. Um, and it will just have public and the name of your class, right? So exactly the way you have written the name of your class is exactly the way you will write the name of your constructor. And like I said, a constructor is a special type of method that is used to initialize objects. And um, if we were to look at the scanner class, you will see that the system.in operator is what you find within the parentheses there. We'll talk about that there. And then here we say a constructor must always have the same name as its class, like I said earlier on. So we can have this value here, and because this class is public, we can so because this class is public, we also have this constructor that's public. So we can just say my field is equal to 1. And this is known as a default constructor. So a default constructor does not have any arguments within its parentheses or parameters. Has no arguments whatsoever, and you can just call it at any time and at any place. That is what you call a default constructor. Okay, so a constructor can also pass in arguments, right? So earlier on, I talked about having arguments inside here, and we've talked about the public for my class and having the importance of why this guy must have the name of its class itself. So let's look at a an example of a constructor with arguments. So we have public class or public my class, and then we have int number. So in this, like I said, constructors are special kinds of methods. So if it's a method, it must pass in values, right? So meaning we have int number there. Open our fields, and then we can declare this field that we have declared here in our data fields as number. So you can declare it as so. So we have this type of scenario here, and we also talk about field access. So field access, we're going to go back to what uh, access modifiers are. So access to fields can be adjusted to provide better security and better usability of code. This term is called encapsulation, and it is a very important concept in object-oriented programming that will help, or that will differentiate you from a novice programmer, right? So we have these access, like we said, we have public int my field. So meaning my field is public, and when we declare this name as private, to say private string name, then it means that this is only accessible throughout the class itself. And we can say we can just leave it as that the way it is. It will automatically inherit the access modifier of the class itself. So if you leave it as blank just like that, it means that this radius is going to be declared public automatically. All right. So with that being said, we can see that here, if we declare this guy as private, then it means that uh, it is not accessible in this constructor. So for us to be able to get this field or this my field to be able to be accessible in this my class, notice that this is private and this is public. So this cannot access this. And if you name this private and leave this like this, it will give you a syntax error saying that I do not know what this is. I do not know where this is coming from. I do not know what this value actually is. So once you say that, if you want to make this guy into public and make it accessible, you use the this keyword. And the this keyword basically gets every value that is here that is declared public, protected, or whatnot, and it conforms it to the access modifier of whatever we are calling it. So if I put this on this guy here, it means that this field is going to be public and this field is going to equal to number automatically. If you put it in your constructor and then you declare this field, this my field equal to 1, then automatically this my field becomes public as said. Hope that makes sense in some way. So we've talked about constructors and the this keyword and basically how everything operates. So now let's talk about methods. And general outline of classes are simply the class itself, the class name, a constructor, and a method. Always. Class, data fields, constructor, methods. That's what classes in Java are typically composed of. So we've talked extensively about methods in our previous videos, but now we're going to talk about methods using object-oriented programming. And methods define the behavior of a class. They represent actions that objects of the class can perform. So there are special methods that can help access the information in the method that will blend well with object-oriented programming. So we have getter methods and setter methods. And these getter methods allow the program to get the method from the invoked class, right, to pull it out of that class and bring it into your main class. And then you have the setter methods. These allow the program to change the variables of the class in general. So let's look at a typical example of a getter and a setter method. So here we have our constructor with our arguments, assuming that we have put in our data fields and all that. We have public my class int number, and then we have this my field is equals to number. Great. So now here we go to our methods and we say public void. So this is a syntax. This is a different syntax that we actually take. In a previous video, I talked about the static method, and the static basically means that whatever we do in that class is in that class. We're not getting it from any outside class, or we're not getting it from anywhere else. It's just within that main class itself. But now we are not talking about the main class, we are creating our own classes. So meaning we do not need the static variable anywhere else. So we have public void, meaning this guy has got no return value, right? We talked about return values in methods, and we have public void set value. So here we have a setter method, and we have an argument in the parentheses. So setter values have got two things. Setter values has arguments and no return type. So a setter value is void but has an argument, right? And we declare this my field is equals to new number, and our getter method here we have public void as well. It has no arguments but has a return type. So that's the difference between a setter and a getter method. A setter method has arguments and no return type, but a getter method has got no arguments but has a return type. So you can try to get in the you can try to get in the concepts of methods. You can go back and try to play around with codes here and there and try to see what you can do. But before that, I'm going to teach you how to compile your code so that it is used concurrently later on. Okay, so with that being said, that's the general class outline, and now let's just go into actually compiling your code. With that being said, I have sample code for you here, right? So we have our class here that we have created. So I have public class, my class, right? Good. So this is my class that I have created, and say our data fields are int my fields. You close the statements there, and then we add in our constructor. It's a default constructor here, and it means that we have no arguments. We can just call it the way it is, and then we say public my class, and then my fields is equal to 1. So because this guy is public, this guy is public as well. Oh, because this guy is public, this guy is also public. So there's no need for this keyword, right? So we say public void set value. So we have our setter method there, and then we say int my fields. And once we declare this my fields as integer, so this could be anything. It could be your name, it could be anything. Like I said, it's an identifier, right? So we open this method, our setter method, and then we declare this my fields. So whatever value that is going to be my fields in this guy here is going to be equal to that guy. Hope that makes sense. This keyword allows for whatever data type that is here to be that guy. So we just say we're basically overriding whatever value that was to be what that is, right? Great. So that's our setter method. And then now we have our getter method, which is get value, and say public int get value. And then it has got no argument, but it has a return type. So we say system.out.println, your new number is my fields, right? So here there's supposed to be a closing statement, so you can just close that there. Or let me just edit this. So now that that's fixed, we have returned my fields. Okay. So whatever value that we're going to put in here in our setter method, that value is equal to that. So this is my class, and this class actually changes a value from one value to another value, right? Great. So now this is my secondary class that is going to implement this class outside of the class. So I talked about static methods, and the reason why we call this static is because whatever this thing is, whatever this method is, it is being directly referenced in this class alone. It is not being called from any other class. It cannot be called from any other class. It just is, right? So we have our public static void main string our guess, and then we have our scanner input equals to new scanner. So the scanner class is basically built like this. It has a name which is scanner. It has got the data types. It has got a constructor, and this is the constructor for the scanner class. And these are the arguments that you have put in the scanner class. These are the arguments that are in the scanner class as well. So this is the object that we have created. It could be any name, depending on what we want. And we have our scanner input is equals to new scanner. So we use the new operator to be able to get an instance of that. So an object is basically an instance of a class, basically, right? It allows us to get access to our class in this order. So we call our class here, we say my class here, object. So this could have been anything. It could have been Trey, it could be Chella, it could be anything. So we say my class object is equal to new my class. And because our constructor does not have any arguments in there, we have a default constructor in there as well. And then we close our statement. And then now after we've created our object or our my class object, we say system.out.print input any random number, and then int number is equal to input the next int, and then the system.out.println your number is that, and then we have this guy and say system.out.print, what would you like to change it to, right? So now here we are prompting the user to say, hey, what would you like to change this to? And then we have number is equals to input the next int, and then we say object, this guy here, dot set value. So the dot operator is saying that, okay, we are getting this object and we are calling this method here. And then because this argument passes in an integer, we say our number in there. So once we set in that value there, this whatever number that is that we put in the beginning is going to be changed to that number. And then we have object.getValue, because our get value does not have any uh, arguments. We are just going to get it like that, and it's going to output your new number is equal to my fields. So enough talking, and let's try to see how this looks like. So let's try compiling that, and we say Java C. So the Java C operator will compile the display class, and it's also going to compile the my class, like so, like so. So we have display the Java and my class the Java, and this is going to create one class that will have a main method. And so now, because our main method is display, we're going to say Java display, and we're going to say display.java, and it is going to give us our output. So now we have input any random number, and let's just say we put in 6, right? So it says your number is 6, and what would you like to change it to? Let's say we change it to 10, right? So we see that our new number is 10, and the number has been changed from 6, it has been changed to 10. So the new number in our class is equal to 10 at that point. So we see how we can use classes to be able to implement what we want in that sense. So next up, we have a different type of code that is a little bit slightly complicated, but it uses the same concept as before. So before we get into this, I just hope that you do understand how to actually go about object-oriented, right? Object-oriented programming and how to compile your code. It is very important you know how to compile your code, because for me, it took a while, but I eventually uh, got it through, right? So anyway, without wasting any time again, let's just go into our second line of code. So we have public class car. So we have a relationship between car and my car here, and we're gonna see the output. It's really interesting. It's really dope. You're gonna see it. So we declare this make as private and a string, and we say private string model. So we're going to talk about the make of a car and the model of a car. So we also have public car string make and string model. So now this one implements that the constructor that has the values, or it has arguments in it. And then because these are private, we are going to say this make is equal to the make that we have there, and then this model is equal to the model that we have placed there. So now we have a method, which is a string method, and public string get make. So this is a getter method, no arguments, but a return type, right? Great. So we have this string get make, and then we have public void set make, and we have string make, which is our arguments there, and then this dot make is equal to make, like so. And then we do the same with model. Pretty simple, right? Nothing complicated and all that. So now we have our car class, right? This is what define our car. We can say a car has got the attributes of a make and a model. So we know that the make of a car is, let's just say we have a Lamborghini, and the model is an Aventador, right? So we know the make is a Lamborghini and the model of the make is an Aventador, right? So we have a class, which is a car generalization of everything, and we can have a make and a model. So we can declare these as private, and then we say this make and then this model. So we declare this private for protection and security. You know the drill and everything. So now let's go to our actual output. This is the code that is going to be output during the command terminal. And this, because this does not have a static void main, so it will not run automatically. That is very, very important. A class you create will not be able to be accessible in the main method unless, or let me just say, the class that you create is not going to be viewed alone because it will require a main method to actually operate. So you can go to you can make a new line of code and say import java.util.scanner, and you've got public class my car, and you've got public static void main string args, you know the drill, and we have scanner input is equals to new scanner system.in. And then we have system.out.print what is your dream car and its model. And then we say string make is equal to input.next, string model is equal to input.next as well. So now we have car, right? We're getting the car there, word for word, line for line, character for character. So I got CAR, capital letter C, small letter R, and small letter A, and we get it like that. And then we make our object as my car. So this is going to be the object that we're going to be using throughout this code. So we get car, my car is equals to new car, and then we have our make there, we plug it in there, model, we plug it in there, and we close our instruction. So we say system.out.print line, wow, your dream car is really a my car dot get make. So meaning that once we have this guy here, and once we've invoked our constructor, so meaning whatever we put in here and here becomes what goes there and there, and that's what gets there and there. And if we say get make and get model, so whatever is get make here, we're going to return make, and get model, we're going to get model like so. And we invoke it using the myCar.getMake method. And then once we put that there, we say, is there any other car you love? And then we string answer is equals to input.next. Great. So we declare a few things for interaction purposes. We say character yes is equal to y, and character no is equal to n. And we use these guys, say if answer, right, this guy, dot to lowercase dot character at 0. So we say whatever the user inputs there, let's just say capital letter yes or no. Because we code this as a string, we're going to say the user can put in as many number of characters that they choose. They can put a whole sentence there. But so long as you just start with yes or no, we have this type of method or this if statement that's there. So we say answer dot to lowercase. We put it to lowercase because that's the case that's there. Dot character at 0. If that guy is equal to yes, so yes here we've declared it as y. So we say if answer dot character to lowercase a character at 0. We say if the answer is yes, we say system.out.print, could you please tell me? And then make, because we've already declared make as a string, so we just call make is equals to input the next, and then model equals input the next. And then we set get my car dot set make there, and we got my car set model. So here we're using setter methods. We are using getter methods here, and now here we're using setter methods. So now after we have set everything to that, let's say system.out.print line. Amazing. You also love the whatever car you put in there, the get make, and then whatever that there, and then you have you, my friend, of excellent taste. So if this guy here is equal to no, or let's just say you input no, you're just going to say you're going to have, well, the make plus model is really amazing. So this is practically really dope, and let's try to see its outputs. So we have our code, and we say Java C. We just compile the two classes, and we say car dot Java, and we also say my car dot Java, like so. and once it compiles, it's going to give you that, and then we say Java, and then we have my car because that's where our main method is, and we compile that. So we have what is your dream car, and let's just say my dream car is a Ford Ranger, right? So if it's a Ford Ranger, we have wow, your dream car is really a Ford Ranger. Is there any other car you love? And if I say yes, and the program's going to tell me, could you please tell me? And let's just say a Nissan GTR, right? And we're going to have our output, which is amazing. You also love the Nissan GTR. You, my friend, have excellent taste. And if we could try this again using no, we say a Ford Raptor is my dream car, and then I'm going to have the same response, and then here using the no operator there or the no option, I'm still gonna get the Ford Raptor output. So we get to see the implementation of classes and how you can create classes and how you can reuse your code accordingly. It makes coding way easier, and if you require like code that has okay, that is very complicated, you can just use classes to be able to implement your program. All right. So with that being said, there's a concept that I want you to learn before we end this entire video course. So we have a unified modeling language, also known as UML. And this is a diagram that outlines the attributes of a class. It's basically the diagram that visibly illustrates how the class is outlined. Rather than you having to analyze the code, the UML can help you locate where certain attributes are or methods and how they are structured. So let's just look at the UML of the car class that we're just from creating. So because we have declared this make as a string and private, so we're going to say the name, which is there, and then the minus operator there is a representation of private. So wherever you see minus, that's private. Wherever you see plus, that's public. So that's just something that you need to get uh, knowledge about. So we have our car class, we have our class name there, and then our data fields. We have private make string, and then the private model string as well. This is this guy over there. And then we have our methods. So like I said before, a constructor is a special kind of method, so it goes into the methods section. So because this constructor is public, we're going to have a plus, and then we're going to have car. And then here we have make and string. So we have make string, and then we comma there, and we have model string. So we have that there. And then we don't include these extra stuff. We just get the actual structure of how the methods are implemented. So we have our get make methods, and because it's a string and it's public, we have public get make, public string get make, and same as the set make, and which is void here, and we have the void there, set make, and then we have our arguments in there, and then we have get model, which is a getter method because it has no arguments. We have that guy, and then same as set model. So this is just a basic representation of the UML, and this is how to actually implement it. So you can just look at it, study it, and try to come up with your own type of UML. And with that being said, if you understood that, if you didn't, please comment down below on basically if you didn't understand it, or you can email me and I will see to it that you get the full experience of how this actually works. Anyway, so we have radius, double, and circle. So this is a challenge for you, and I've given you this UML. If you understood the previous concept or the what we're just from talking about, then this should not be a problem for you. So just try to implement whatever you feel like implementing. So this is the class, the circle class, and we have a our data fields here. And this guy is a constructor, so don't don't be alarmed or anything. This is a constructor. It's not supposed to be there. It's supposed to be in the method section. but you get the idea. So try to write code for this UML for the circle class, and try to output it and see if you can uh, manage to write your code. Okay, so that's it for this video course. If there's anything, I will make videos according to your requests. But thank you so much for the views and the likes and subscribes. And if you're not subscribed, please like and subscribe to this video. Thanks for watching and happy coding. Take care.